So good afternoon, everybody. So we are going to start this section 3 of this conference, and the presenter will be Dr. Khaled Belouchet from the University of Misila in Algeria. Is there? Please put your camera and your presentation. I don't see you. I don't see the speaker, Daniel.
Let's ask again. Khaled Belouchet, are you around? Okay, this is the first person who is not coming up. Khaled Belouchet. And maybe the person thinks that we start at 6. Okay, the program is 16:20. What's the time? The time now is 16:19. Let's just wait. Because that will be the first person.
Wait 1 minute.
1 minute.
But...
1 minute. Yeah.
Okay.
Now, because normally, but the person ought to be already in.
Yeah, I think so.
Yeah. So this will be the first person who is not presenting. Not all the presentation has gone up through without any interaction. So it will be funny. If the person could not, then let the person let us know on time. Not.
No, he doesn't appear. How do we proceed?
Yeah, we will take the next presenter. If he doesn't, let's just wait. Let me just see once more, Miss Dr. Khaled Belouchet. That's not. Okay. So is Joel Ezenwora already around?
Yes, sir.
Okay, so you can you proceed?
All right, sir. Let me share my screen.
So you share your screen and then you start. Yeah. To gain time.
Okay.
So Maria, can you present the next speaker? You can just present him and before we start.
Sure. I am going to present now Dr. Joel Ezenwora. Dr. Joel Ezenwora.
Yes, Prof.
Excuse me, are you listening to me? It's okay, the sound?
Yeah.
Yeah, okay. So Dr. Joel Ezenwora studied physics electronics technology and has a PhD in atmospheric physics in photovoltaics. And he has done a lot of work in this field with many publications in reputable local and international journals, mostly on electronic circuit designs and solar electricity. He has equally published a book in Germany, and is printed in USA and in the United Kingdom. The book is on electronics and is titled Electronic Moving Display Technology, Designs, Basic, Characterization, and Construction. And so he is supervising undergraduate and postgraduate projects in these fields. He's member of ANSOL since 2019. And so I will give the word to Dr. Joel Ezenwora, please.
Thank you, Prof. Let me share my screen. Can you see my screen?
Yes, if you can put this in the screen way, it will be better.
Okay.
Yeah, in this one.
Presentation mode. Put it in presentation mode.
Presentation mode. Yeah. That's it.
Can you see it? Hello, Prof.
Yeah, it's okay. I think it's okay.
Okay. All right. Thank you, Prof. And thank you, everyone. Every other protocol observed. My presentation is titled Performance Response to Ambient Parameters and Modeling of Polycrystalline Photovoltaic Model in Minna, Nigeria. Manufacturers of photovoltaic models rate their models under the condition known as standard test condition, which is at 100 watts per meter squared solar irradiance, 25 degrees centigrade cell temperature or module temperature, and 1.5 mass ratio. This is a laboratory controlled condition, and this condition at a stance can hardly occur outdoors. So there is need for a photovoltaic model to be evaluated, for its performance to be evaluated outdoors to ascertain the realistic outdoor performance of that model before it's deployed for power system. And here in Africa, typically Nigeria, the problem is compounded by the fact that we still have photovoltaic models whose actual or realistic performance are below the nominal value. In this study, a polycrystalline photovoltaic model was deployed outdoor for performance evaluation in order to obtain the realistic outdoor performance variables. And this is the experimental setup, which is based on CR1000 module with computer interface from Campbell Scientific. You can see the models deployed outdoors with every sensor that is needed in place. The sensors that measures atmospheric parameters, which are solar irradiance, air temperature, module temperature, wind speed, and relative humidity. And the performance variables of the modules are open circuit voltage or circuit current, power, and maximum power. This was monitored for a complete year in order to cover the seasons, different seasons of the year in the study area. And this, as performance parameters vis-a-vis the performance variables were studied accordingly. Now, as data analysis, few factor was evaluated: efficiency, module performance ratio, and statistical analysis was also carried out in order to ascertain the rate of each variables for the performance prediction of this module, as stated. Now, the first figure, figure 1, is the IV characteristics of this polycrystalline model at different level of irradiance. as you can see, the figure depicts what is already known, that short circuit current or current of a module varies, in a regular or in a directly proportional to irradiance. In other words, comparing to voltage axis, you can see bunching, which shows that voltage of a photovoltaic module doesn't have a linear relationship compared to current. As you can see at the current axis, y-axis, you have a relatively regular spacing of the plots. And then the figure on the right, also comparing the module temperature and open circuit voltage of the module. Again, we can see that at the open circuit voltage will increase, and then getting to a certain point, temperature at a high temperature, the voltage, it doesn't increase anymore. And you see, I can see from the plot, this is in accordance with other researchers in the field. In figure 3, comparing module temperature with short circuit current, we see that short circuit current again shows linear relationship with the module temperature. And at the figure on the right, we can see that maximum power traces the profile, or has the same profile with short circuit current. Now, in comparison between efficiency and temperature for the Polycrystalline model, but also efficiency is usually high at a lower temperature. At the lower temperature, and when the module temperature starts going higher, the efficiency will start dropping. And so the figure forms a symmetric, it forms a symmetric figure with a maximum power. And this is also in agreement with other researchers in the field. Now, in figure 6, we see the hourly average variation of open circuit voltage and short circuit current of the Polycrystalline silicon model as a function of time for the month of January, a typical dry season month. And then in it, we can see again that open circuit voltage is peaked at early hours of the morning before the modules start heating up, while the short circuit current peaks in the afternoon when the module is already hot. And again, power traces the profile of open circuit voltage. The power of a photovoltaic module, start dropping when it gets to a higher irradiance, which means a higher temperature. While the Pmax also traces the profile of the short circuit current. Now, looking at the table 1, which is monthly average values of ambient parameters with performance variables, we can see January in the study area has the highest wind speed, 1.99 meter per second. And in comparison with February, which has the same, almost the same irradiance with January, we can see that the wind speed favors open circuit voltage because when the wind speed is high, there will be rapidly transferring of heat from the module to the ambient, which invariably cools the module. And then you see that the high wind speed favors the open circuit voltage better than the short circuit current vis-a-vis other factors. And then from the table 2, we can also see that efficiency peaks at lower irradiance, and this table at 375 watts per meter squared. And then when the irradiance starts going higher, and that means higher temperature also, the efficiency starts going down. So sunlight and the heat is not everything. And again, looking at below of this table 2, at 1,000 watt per meter squared irradiance, which the manufacturers usually use to characterize, to rate the model, you can see that the module temperature is not 25 as manufacturers will normally state. As standard condition will normally state. Here, you can find out that you can see that the module temperature at this 100 watt per meter squared is 41.7 degrees centigrade, which invariably will affect negatively the performance of this module at that particular temperature. And the maximum power recorded for this module is 1.3 as against the manufacturer's specification. As the specification of manufacturer is 10 watts at this particular irradiance level. And you can see that at this irradiance, this module never recorded 10 watts as a maximum power, which you can imagine what would have happened if the STC data is used for designing or sizing of a PV power, as it were. And then for the prediction model, Minitab 17 was used for the statistical analysis to produce a prediction model for this photovoltaic model, Polycrystalline. And as a VOC, we have the prediction equation as follows, as this on the left, meaning that open circuit voltage has intercept at 1.11. And then for every increase in solar irradiance, for every unit increase in solar irradiance, there is increase of 0.00564 in this model. And for the module temperature, for every unit increase in module temperature, there is an increase of 0.0523 in this model. And then for the short circuit current, we have them also as given on the right. Now comparing the predicted values with measured values, for the open circuit voltage, the plot is on the left, and then the red plot is for the measured value, and then the blue or the light blue is for the predicted model, predicted open circuit voltage. Then on the right we have, on the right we have the measured value of short circuit current and then the predicted value or the predicted model for the short current, and we can see that because the short circuit current has the linear relationship, you can see the plots. They are in they look alike for short circuit current. Then the prediction model for the power is also given, and comparing, looking at the figure on the left, just like as stated before, the power usually track the profile of open circuit voltage, as you can see from the figure on the left. Sorry, we have just like the way it is in the open circuit voltage. While on the right, maximum power, just like I earlier said, also tracks the profile of short circuit current, and then comparing the prediction and measured value, you can see that they also look alike. Output achieved for the model at a radius of 1,000 watts per meter squared was 1.323 watts per meter squared. 1.323 watts, which represents 13% of the manufacturer's specification. You can see the disparity in their values. And the efficiency also peaked at 375 watts per meter squared irradiance, are representing 10.1% against the manufacturer's specification. And at 1,000 watts per meter squared, this efficiency reduced to 6.20, as against SCC specification of 48 as calculated from this model. So we can see STC is a suspect. It's not meant to for a lot of people, especially in Africa here in Nigeria typically. They get model, they pick it up, they will just use the specification behind the model, which is done at STC, use it to size photovoltaic model. Judging by what we discovered here, we can see that there is a disparity in the values given by the manufacturers from the one that is obtained realistically outdoors. And aside from STC data, we can see the variation in the manufacturer specification from the realistic values obtained. We can see that aside from STC problem, we have what we call overrated modules entering our shores. Overrated, highly overrated. In fact, in the words of our assistant DG Naseni in a 2016 Solar Energy Conference in Nigeria, he said that over 90% of modules entering Nigeria are overrated. So we can also see that there is a kind of dumping on us, because maybe they know that we don't do this research as such. And also, as I said earlier, at 1,000 watts per meter squared, the module temperature is never 25 degrees centigrade, but 41.7 degrees centigrade, as against manufacturer's specification. So, as I said earlier, aside from STC, there is overrated models entering our shores. So, as recommendations, one, we need to be carrying out widespread research. Widespread research that any place in our shores where a module should be deployed for power, for PV power system, the module should be evaluated outdoors in such a location, because aside from the problem I mentioned earlier, these atmospheric parameters vary from location to location. So we need to ascertain its performance in a particular location before we can deploy them for power system so that we can have an efficient and reliable PV power system. In Nigeria here, you see most pilot projects we have, after they can't stand the test of time. After a while, you see them, they're off. And then people will discourage in using the best type of electricity that's evaluated in the world, which is a PV power system. People will be discouraged in using them, saying they are not reliable. But that's because of technical, insufficiency. And then there should be, just like it happened in other climes, in developed climes like US, there should be a means where data will be collected, and then policymakers, will be informed to make the right decisions, and then installers and installers should be made to abide by the research findings in the installation. All this will help in improving our PV power system and encourage people to go into it, because as far as we know, solar electricity is the best form of electricity ever invented by man. And there should be also a mechanism in place to checkmate dumping and evaluated models entering our shores. Thank you for your time. Thank you for listening.
Thank you very much. Thank you very much, Dr. Joel. I would like a very interesting presentation, a very interesting data. I would like to pass the word for questions to the audience. Is there some question? Any question?
Question, Joel.
Sir.
What does the government do to see which panels are entering into the country?
Sir, in Nigeria here, we have an agency called Standard Organization of Nigeria. But I wouldn't want to be political, but they don't have the capacity to investigate these models. They don't have capable, they don't have people that knows these things in the organization to evaluate the performance of these models. So they will either use other means, because a lot of them are here. If they know what some of us know, those things will not be entering. This model, for example, as it is, it cannot enter South Africa. Because I know they do more researches than not. But here, you see a lot of all manner of models, substandards, even entering Nigeria. Some people will use it, and then eventually, when it's used for power system, it will not stand the test of time, and then people will be discouraged in using them, saying that the PV power system is not reliable. But it's not true. So the government need to do more. They need to do more. The government of Nigeria, for example, need to do more. They need to employ capable hands that will actually know how to, evaluate these models to know whether they are overrated or substandard.
One question is, but
your microphone is muted. Daniel, your microphone is muted.
Daniel, your microphone.
Yes, sir.
Yeah, I'm saying the federal state, can it not do something? The federal state, the state of Niger could do something.
They can.
The central state cannot. The central state in Abuja, but the federal state in the capital of your state is Minna.
Okay, the state government. Yeah, microphone, sir.
Can the federal state of Niger, the Niger state itself, can they do something?
Niger state government.
Yeah.
Well, they can also, but I'm sorry that the Niger state government they don't have men at entry points. Where these models are entering Nigeria. Most of these models enter through the sea, through sea, and sometimes through air. So they can have the international airport we have in Niger State. It's not mainly used for importing items. So the bulk of it lies in the hands of the federal government. To put men at entry point, check these things, evaluate these things before they enter. Because before it must have entered Niger State, it must have entered Nigeria.
You are right. You are right. I see. Yeah, but I think I was in Minna. I came to the university last 2 years ago, and I saw the electricity problem which was there, and I was asking. Yeah, and I had to meet the VC. Actually, and saw sign an agreement, an MOU, that we should help the University of Minna, and at the long term also provide some services in the state of Niger when it comes to installation, training, and so on. We hope that this cooperation will function after this corona pandemic.
I pray so, sir. I pray because it's a very big problem. There was a PV power system that was to power a segment of the Boso campus. The preliminary studies there, for example, it was used as a pilot project in the campus. But I tell you what, this PV power system only, succeeded. It only lasted for testing. It was tested, and that's how it blew off, and that's the end. Colossal West now. The panels are being vandalized. If you go there, I cannot see even up to 5 panels there now. And this is a very huge, acres of land with these panels. So they only tested it. Sometimes they don't. I don't know. Politics, they don't employ competent hands to do these things. And then I personally went to state government, through the Ministry of Science and Technology when I was doing my PhD. I explained everything to him. He told me that yes, I'm right. That some people are causing, if we are consulted, some problem will not be there. But they sometimes they don't care about what the functionality of the issue, what they adjusted in the contract, how much money does enter their pocket. So it's a big problem. The problem is political.
Who is asking a question? I think Ale, you can. Your phone is your microphone is muted, so put it on, Ale.
Okay, thank you very much, Daniel. Thank you, Zarel, for your presentation.
Yes, sir.
I have just one question. Yes, sir. During the panel measurement, did you take into account the environment? Such I want to. If did you control the impact or the effect of the dust deposited on the panel, on the modules?
No, the dust factor was not studied, was not taken into account. It was, but we intend doing that subsequently because we will need a control panel to study that. We'll use one when we'll be cleaning the modules, and one with the module not cleaned. So the dust factor was not taken into account as far as this study is concerned. But we intend doing that subsequently to obtain the dust reduction factor. Because just like I said, in other climes, like US, every location, they have all these factors. They have the dust reduction factor for example, California state, which may be different from another state. So they have these factors which they apply whenever they are trying to size, PV power system. So we need to be doing something too here. But, in fact, we did not take into account this dust factor in this particular research.
Okay, thank you.
There is this Mites now who want to ask a question also.
All right, sir.
Yeah. When I look at your current voltage curves and the results that the efficiency goes down with higher light intensity or more irradiation, both look like you have problems with conductivity or contacts. Are you sure that the problem is in the module and not the contacting of the module?
Pardon, please, I'm in a noisy, I didn't get you very well. The problem. Hello? Hello?
Dita, can you repeat your question?
Well, I asked my question already.
Since you did not listen, you did not hear well. Can you just
hear it? Okay. When I look at your current voltage curves and the result that the efficiency goes down with higher illumination, both point to the fact that you have problems with conductivity. Are you sure that the problem is in the module and not just contacting the module and maybe in your own setup? Did you check what the reason for the misbehavior of the module is?
The problem is not from the system. This particular model, based on the specification given by the manufacturers, the electronic load that is used for it was specifically designed for the module based on the specification. And from the experiment, the electronic load was programmed, or the logger was programmed to scan the electronic load at, or to load the panel at intervals of 50 milliamps intervals, which will give about 20 data points until the current or voltage drop to zero. But from the experiment, we can hardly get 5 data points before it drops to zero. So showing that the panel as specified by the manufacturer could not even deliver the 1 amp it was specified to do. So the problem is not from the setup. The setup is highly automated, and then from the result we see that the module is highly overrated. In fact, before deploying the module for the experimental setup, I personally did manual measurement on the module using multimeter. When you measure the voltage, it will go to nearly the open circuit voltage or open circuit current. Open circuit voltage as supposed. But once you load once the panel you load the panel, it will start going down, and that way. So the problem is not from the experimental setup.
I'm not convinced.
Dito, you are saying something, but your microphone is muted.
No, I just said that I'm not convinced. The current voltage curve is so funny that it needs clarification why the module does not behave well. And of course, the fact that the setup is expensive and automatic and whatever does not mean that you cannot make mistakes when you contact the module. If you have a contact resistance, you may get this kind of response.
Can I come in? Hello?
You have 2 minutes.
Okay.
But before the next talk.
All right. This module, this polycrystalline module was not the only module studied. we studied amorphous, we studied monocrystalline from the same company. And they all have the same characteristics. They all behave the same.
So this just means that you have more evidence that it does not come from the module. If they all behave the same, it may be outside the module. But I think we will not clarify this. I just would advise you to really look at the current voltage curve and wonder why they look so funny.
All right.
Okay. Is there another question? Okay. So I think, Daniel, can we pass to the next speaker? Daniel, your microphone is off.
Okay, you say?
If we can pass to the next speaker.
Yeah. Mm-hmm.
Is the time? Okay. Our next speaker is
the next speaker is Moussa from
Moussa Bougouma.
Yeah. So
sorry, my microphone it was mute. So the next speaker is Moussa Bougouma. He is an associate professor in the field of physical chemistry and electrochemistry at Norbert ZONGO University. His research work is diversified, but mainly focuses on the study of semiconductor materials obtained by thin film electrodeposition or by chemical vapor transport. These materials have been studied for various applications, including solar energy conversion. Dr. Bougouma research also focuses on the implementation of physicochemical and electrochemical methods for the study and treatment of water, materials, waste management of electric and electronic equipment, like batteries, telephone, etc. And also from wastewater or discharge from mining. So Professor Moussa Bougouma is currently the director of the Faculty of Science at Norbert ZONGO University. So I pass the word to the Professor Moussa Bougouma.
Thank you very much.
Please, go ahead.
I send my presentation. You can put it.
You can share a screen.
Please.
Essayez de partager votre écran.
Oui, j'ai partagé, c'est bon?
Mais
OK?
on voit, ouais, vous avez partagé, je vois seulement le truc. Et cliquez sur votre présentation.
Vous voyez la présentation maintenant, c'est bon?
Vous avez cliqué là-dessus, je vois seulement le fichier où la présentation est.
Oui, mais moi j'ai projeté ici, vous ne voyez pas?
Nous ne voyons pas encore.
Vous voyez?
Non, nous voyons seulement le fichier. Essayez de cliquer là-dessus pour que nous puissions le voir.
C'est bon?
Pas encore.
It's good now?
No, it's not yet good. Click the file. We are seeing and all this MS and so on. Click it so that we can watch, we can see your slides.
On peut cliquer à quel niveau? Parce que
Le problème, c'est que nous voyons seulement le compte de. Vous avez ouvert un fichier avec différents.
Alors,
ouais, maintenant
voilà.
on le voit. Maintenant
Voilà.
on voit. Maintenant on voit. Ouais, okay.
Maintenant, on voit.
Ouais.
C'est bon?
Ouais, c'est bon maintenant, ouais, c'est bon. Parlez en anglais alors.
Okay, thank you very much. My presentation, my name is Moussa Bougouma. I'm from Burkina Faso, Université Norbert ZONGO University. My presentation, I'm going to present my work. It focuses on growth and characterization of transition metal decalcogenide for various applications. The outline of my presentation is, first, the introduction, followed by the technique of material synthesis focuses on chemical vapor transfer. After, I will present the different results of material characterization, and finally, the different application of this material, followed by the conclusion. About the introduction, it's well known for everybody that the energy for the future is solar, and Burkina Faso is in this dynamic. That for two main reasons. First, we have the first largest solar power plant in West Africa, maximum capacity of 33 megawatts established on 60 hectares. Second, we have Faso Energy, the first solar plant manufacturing plant in West Africa. I want to speak about the motivation, but everybody know that. But it's important to know that for solar energy conversion into electrical energy, the famous material used is silicon. However, new materials are starting to emerge, in particular with transition metal decalcogenide, in which we have selenium, molybdenum diselenide. So the second part of my presentation will focus on the growth of selenium diselenide single crystal by use of chemical vapor transfer technique. The first step to grow this material, we have two steps. The first step is the synthesis of the powder, and for the synthesis of the powder, we have to wet molybdenum and selenium in stoichiometric condition and put them in the tube. Then the tubes are connected to a vacuum pump in which we make high vacuum to avoid oxygen oxidation. After this step, the tubes are closed. We close the tube using a torch and placed in an oven where the temperature is increased to 750 degrees for 1 day, and we maintain this temperature for 5 days. Then the product form is allowed to cool down for 24 hours. The tubes are collected and the powder is ground. The same process is repeated and then annealed at 1050 degrees. The polycrystalline powder obtained undergoes several types of characterization. Then the same show that, so after the synthesis of the polycrystalline powder, we characterize them to see if they are in good quality. The first type of characterization is SEM. So the SEM show that the powder are homogeneous and perfectly crystallized. They are clean and very smooth surfaces. The second type of characterization makes it possible to identify the structure, the crystallines in the hexagonal compact system, what is confirmed what is confirmed by term analysis. After this type of characterization, the second step is to use this powder to grow single crystals. The powder is introduced into a tube in which the transfer agent is added. The wall is closed under vacuum of about high vacuum and then introduced in the grow oven. The end containing the products is placed in the hot zone while the other is placed in cold zone as shown in the figure. Grow takes place for 5 days, then it's allowed to cool for 1 day. The single crystals are recovered and then are analyzed. First type of characterization of this single crystal is SEM. So SEM analysis which show that the surface of single crystal are very clean and does not contain any defect or cracks. EDX analysis coupled with SEM spectra show that the material is not contaminated by the grow process. The spectrum only show that selenium and molybdenum peaks. So we can see that they are not contaminated. XPS, which is higher resolution method than SEM, was also used. It also showed that the samples are not contaminated during the grow process. The synthesis tube consisting of silicon and transport agent containing tellurium and chloride are absent, are shown in the figure. We can see that we just see peaks of molybdenum and selenide. We have also peak of oxygen and carbon, but they can remove by manual cleave. Grow by layering of lamellar structure are clearly demonstrated by IFM analysis, which also used for the material characterization. The value of C parameter is perfect agreement with its early result. After this physical characterization, the electronic properties of the materials were identified. UV spectroscopy were used for identify the band gap energy of these materials, and the value obtained is in agreement with what was found in the literature. After this, we use other type of electrochemical analysis, such as Morshowski curve drops, which help us to identify the band gap and the carrier rate of the materials. All of these results found show that our materials are in good condition. Finally, the electrical conductivity value made it possible to identify the activation energy and the electrical conductivity. The value obtained are in agreement with what was found in the literature. After these results made it possible to use the material for different applications. So after the material characterization, we use them for different kinds of application. The first type of application is to use them in electrochemical cells for energy conversion, as shown in this figure. So the curve obtained show that it's possible to use the material to convert light into electrical energy. We have a curve in dark and curve in light. You can see that there is a very big gap between the two types of curves, which show that it's possible to use this material for the light energy conversion into electrical energy. The second type of application that we use this material to synthesize. Regarding the second type of application, the single crystals have been exfoliated and used to make organic hybrid materials. Analysis makes up CIFM that show that they have good properties and good semiconductor for the conversion of light energy, and the properties studies show that this material can be used to synthesize hybrid semiconductors for solar energy conversion. The third type of application is we use this material for toxic gas molecule detection. And the sensing response as function of gas concentration on this curve show that it's possible to use this material for the detection of the toxic gas molecule. You can see here. After this application, we also use this material for bipolar electrode synthesized. Finally, this material were used to make bipolar electrode. The result obtained are very interesting. Single crystals can be used for several applications. The first type of application is that we can use this material for example, organic molecule oxidation, proton reduction, and hydrogen production. And finally, we can use this material for electrodeposition of many types of metals, such as gold, silver, copper, and nickels. So we can remark that we use this material for many types of applications. In conclusion, we can say that even if in-depth studies are needed to further improve the quality of the materials, the results obtained are already show that they can be used for many types of applications. And I thank all of these institutions which help us for these results. Thank you very much for your attention.
Thank you, Professor Moussa Bougouma, very interesting presentation. I would like to ask for questions.
Yes.
Are there any questions in the audience? I don't see any. Oh, okay. Professor Dieter Meinzer, please go ahead.
Yeah, thank you very much for this very nice lecture. However, you did not convince me that this proves that the material can be used for applications. You know that you have a very complicated material chosen, of course, a layered compound, which when you grow crystals forms platelets of different sizes and so on. And of course, for any application, you would have to arrange these platelets in a certain way, or you use them as a kind of powder, but then of course you have the problem of the very big difference and in diameters in the different directions of the crystal because of this layered structure. So I think in order to really prove that this can be applied, you should develop a strategy how to actually use this powder or whatever you produce in, of course, in your ampullars, you produce a powder, how you can really use these powders for making a device. I don't think it's enough to show that certain effects can be measured, which actually we did already, I don't know, 30 years ago or something with these selenides on the layered compounds. So I think they are very nice scientific materials. However, I cannot imagine, and I have worked a lot on applying materials for practical purposes. I cannot imagine any way that you can really think of making devices from these materials.
Do you have any answer, Professor Moussa Bougouma, please?
Yes. Okay, for this material, it's important to know that the single crystal are reference materials for different kinds of studies. Today, we remark that many studies are focuses on monolayer and thin films, but the reference materials for these different kinds of studies are single crystal. So single crystals are very important for because they are reference material for different kinds of studies. That is one. The second one is that we can exfoliate these materials for different kinds of application. For example, in our case, we exfoliate this material and use them to make hybrid organic compound for which have good properties, semiconductor properties. That is one. And we can also use this single crystal to make monolayers for different kinds of applications. So that I know that it's I know that we have to study different conditions of how to apply these materials, but it's important to know that we can use this material to make many things. I don't know if I.
Okay.
As I said, it's not enough to show that you get the desired effect. The problem is the production of a device. And for production, of course, you need large areas, you need some way of depositing these materials. So thin films, also monolayers, of course, can in principle be deposited on a large area. However, if you have a powder material, first of all, you probably have to select the size by some way to lower down the variation in diameter for practical purposes. And then you have to find a way to make actually a layer or something. And if you have this strong direction dependence, you would probably have to orient your crystals in this production.
Yes.
This is very difficult to really produce. So I think you should really think up a way of making devices from powder. And
Yes.
I'm just writing you my address because I think we are the only ones who really make solar cells or solar modules. We print solar modules from semiconductor powders. So you can check how we do this. I cannot imagine that you do this with layered compounds, though. Thank you.
Yes, you are right. We are thinking now on how to produce this material in big quantities. So that we are thinking on a device, and this work is in progress in our laboratory.
As Professor Moussa,
Oui.
many students want your lecture. Can you send me a PDF of this lecture so that I can forward it to some people?
Okay, no problem. I will send you.
Okay, thank you.
Okay, thank you very much to everybody. And so for attending this session, Daniel, I think that we need to pass to section 4. It's time to pass to section 4.
Yeah.
I appreciate everybody, and thanks for your comment. Are very important for continue advances.
So, Maria Teresa, before you go, I want to thank you very much that that you are here. I know, and that through you, we Unstall moved one step further by creating the platform called Balewa, Bridging Africa, Latin America, and Europe on water and renewable energy applications. So we are happy, very happy to have you, that Latin America has joined us, joined Africa and Europe to come together. I'm happy to have Dieter Meissner here, with whom we did summer school together. And so it's a big family. And this family is growing. And I'm meeting Moussa for the first time today, and many others. I'm meeting you here. So I request you to join this, our dynamic network. Moussa, you are in Burkina Faso. We held, Dita and I, a summer school 2017 in Burkina Faso. And I think this is a possibility of us connect. And our plan is to have student exchange between Latin America, Europe, and Africa. We hope that after the corona pandemic, things can move in that direction. I'm proud to have Maria. You are my sister, and I'm very happy that you did everything to be one of the co-organizers and to be here with us. And we hope to organize something in Mexico. Why not? When everything is over. Yeah. So thank you very much.
Thanks to you. Thanks you very much, Daniel. And I hope and I expect, I wish that all this conference we have a very big success in research and we can move ahead. So we have a big future to share it. Thank you so much.
Thank you very much. Yeah.
Bye-bye.
Yeah. So the next session is the poster session. I hope that Professor Zahir and Professor Louisa Boudiba are around. Are you around?
Yeah, I am here. Good afternoon.
Are you also around? Okay, Boudiba, yeah. Okay. Is also Zahir around?
Zahir has some urgent problems.
Okay,
so I will animate alone.
It's a very long, Professor Dieter Meisner, could you assist? It's spontaneous, it will be good, because it's a very long, more than 10 posters.
I don't hear you, Daniel.
I'm saying, if Professor Dieter Meisner can assist you, two of you. Dieter, are you ready? Hello, Dieter.
So I would like, I don't hear you.
I can do it, of course.
I say both of you can because it's a very long list. So you can both of you can share the moderation of posters. I know Dieter has always been evaluating posters during our summer school and other events that we had, so he knows better how to do. He knows. He has a lot of experience on this issue. So I think both of you can do now that Zahir is not there, so that Louisa should not be alone in the whole thing. So Louisa, you can start, and then Dieter, you can share the task. Mm-hmm.
Yeah. First of all, I want to thank Professor Daniel Egbe to give me this opportunity to attend the 10th anniversary of ONSOL. And I would like also to salute all the pure scientists who work hard to make our life easier without harming health, environment, and finally humanity. So we start this poster section, with the first work for the Professor Lynda Benbahouche from the University of Setif in Algeria, which is entitled An Investigation on the Effects of Buffer Layers Thickness and Doping Concentration on Aluminium GAAS Solar Cell Efficiency. So you have 3 minutes to expose your work and 2 minutes for the questions. Please, you can start.
Lynda,
yes.
Okay, yeah, she's there. Mm-hmm.
Yes.
Share your screen.
You can share your screen, please.
D'accord. Yes.
It doesn't work.
Vous pouvez partager votre écran. Vous avez votre présentation. Comme le poster, vous pouvez présenter le poster comme il est. Et vous,
Yes.
Et vous êtes libre de parler en anglais ou en français. On a permis pour les posters.
Okay.
I'm sorry, I have some problems. You hear me now?
Yes.
Yeah.
Entendu.
So I want to say something first. I would like to thank Professor Daniel to give me this opportunity to attend the 10th anniversary of ONSOL. And I would like to salute all the pure scientists who work hard to make our life easier without harming health, environment, and finally humanity. So we start with the first work, the first poster for Professor Lynda Benbahouche from Setif University in Algeria, which is entitled An Investigation on the Effects of Buffer Layer Thickness and Doping Concentration on AlGaAs solar cell efficiency. You have 3 minutes to present your work and 2 minutes for the questions. Please, you can start.
Yes. So I am Dr. Benbahouche Lynda from the University of Setif, Algeria. My posters entitled The Investigation of the Effects of Buffer Layer Thickness and Doping Concentration on AlGaAs solar cell efficiency.
Can you show us, can you share your poster, please?
How I do this?
Go to partager l'écran. Il faut cliquer sur partager l'écran.
Oui, d'accord. Oui.
Ouais, si vous, you go to share screen. Click there, then you can
Partager le son de l'explorateur. Oui.
Okay, it's coming. Okay. Just wait a bit. Yeah, now.
Yeah, now
it's very nice winter.
Yeah.
Then go on. Click your poster. We are all learning, so nobody is perfect. So everything.
It works now. Yeah. Okay.
Are we start?
Yeah, you
can start. Okay, thank you, Mr. Daniel. Thank you for all participants. Yes. But the title of my papers is the investigation of the effects of the buffer layer thickness and doping concentration on AlGaAs solar cell efficiency. As knowing that simply improving the performance of solar cell at lower cost is imperative to enable the growth of photovoltaics in the global electricity mix. In addition, thin film solar cells have large-scale terrestrial photovoltaic application because of their low manufacturing cost. In this context, to carry out this objective, numerical studies presented by modeling and simulation aiming at the potential of the technology of the materials used in the study of the performance of solar cells, whose aim at obtaining an optimal electric conversion efficiency. The main objective of this paper, these results, numerical investigation of the electric characteristic, the efficiencies, and the form factors of AlGaAs and GaAs heterojunction cell for 3-5 family of semiconductors through the SCAPS software. We remember that our study focuses firstly on the implementation of the chosen materials in the data file of the SCAPS software, and secondly, validation of the model of heterojunction solar cell operation, and it is later used for AlGaAs heterojunction. The software used in the SCAPS is the solar cell capacitance simulator, is digital simulation software for thin film solar cell with heterojunction. It was developed at the University of Ghent in Belgium. The search of the optimal parameters of these two solar cells proposed is different for different regions. The main results. Firstly, we have studied the the most parameters of the source cell using the simulator software, SCAPE software. We are varying the thickness where we have having results that the thickness has a small influence on the conversion efficiency neta, which is decreased with an increase of the thickness. Further, with the field factors increase when the increasing the emitter thickness between the 0.0 micrometer to 0 to 0.6 micrometer. Another objective is the increase in the doping concentration has also a small effect on the conversion efficiency, and the field factors form factor decreases either from 83 to 83.13 to 83.44, in particular for the doping above 5/1019 centimeter. Neta and phi is almost constant. The simulated output parameters of AlGaAs heterojunction cellulose, we have simulated the most factors that the current, the short circuit, the voltage the open voltage and the field factors and the conversion rate. We have changed the heterojunction from type N to type A to type N. The most results are the increase in thickness of the AlGaAs layer has a direct influence on the conversion efficiency, which the conversion efficiency decreased from 18 to 15, and the form factor decreased overall either when the increase in the emitter thickness between the match of the 0.01 micrometer. Further, through the simulation results, we have also even simulating the EV characteristics with effects of doping concentration for heterojunction N. We have seen a small effect on the conversion efficiency, and the factor form decrease of 30 for 17 to 83. Further, that's the same for the heterojunction type N. We have simulated and calculated the main factors, the current, the voltage, and the field factor, and the conversion efficiency. The main conclusion that I have made for this study, that the increase in the thickness of AlGaAs transmitter type N has a direct influence on the conversion efficiency. Moreover, the efficiency net decrease and the form factor decrease from 78 to 58 when increasing the emitter thickness between the match of the 0.01 to 0.05 respectively. Yes. However, the increasing of the doping for AlGaAs transmitter to type 1, type N, I'm sorry, has a small effect on the conversion efficiency that's for the type P. We summarize our results that it's clear to note that the type of effect of the type N or P emitter layer of the heterojunction have significantly influences on the performance of the two studied cells. The emitter junction P perform better than the emitter junction type N. In addition, the doping and thickness also have a direct influence on the improvement.
It's 6 minutes.
Wait.
Yes.
Yes.
6 minutes.
Yes, sorry.
Yeah, continue.
Okay. The last point allowed us to investigate the doping effects, the thickness, as well as the type of doping N and P in order to pass our choice in improvements of the performance parameters, to optimize their conception, and to improve their reliability in electronic applications. Many thanks. I have finished.
Thank you very much for your presentation. Is there some questions, please?
Yes.
No questions? So we pass to the the following poster for Mrs. Loubna Benhabib from Abou Bekr Belkaid University from Tlemcen in Algeria, which is entitled Comparative Study of Two Calculation Models of Solar Radiation for a Parabolic through Collector in Tlemcen in Algeria. So please, you can start.
Bonsoir.
Bonsoir.
I want to precise that we allow people to speak in French for the posters, because there were many students who have difficulties in speaking English. So bear us when somebody speaks in French. Okay.
Ah, donc, vous pouvez parler en français.
Merci beaucoup. Merci. Bon, tout d'abord, je vous remercie pour la chance que vous m'avez donnée de participer à cette conférence. Et je voulais vous souhaiter un joyeux anniversaire, un bon anniversaire et plein de succès. Alors, je suis doctorante, Madame Benhabib Loubna, à l'Université de Abou Bekr Belkaid Tlemcen. Je suis en préparation de ma thèse, en finalisation de ma thèse. Donc, un des travaux qu'on a entamé, c'était de faire une comparative study of two calculation models of solar radiation for a parabolic, in Tlemcen. Donc, c'est c'est-à-dire une étude comparative de la calculation de la radiation solaire. Est-ce que c'est partagé? Est-ce que vous voyez le...
Skip all the introduction.
Oui, c'est partagé. Mais soyez bref, s'il vous plaît.
Oui, bien sûr.
D'accord.
Go to the results directly, please. Otherwise, we will never make it in time.
Vous pouvez présenter directement les résultats.
D'accord, ça marche. Alors, on a choisi deux modèles de calcul, c'est-à-dire on a choisi un modèle de Cap-des-Roues et le modèle de Bird. Le modèle de Cap-des-Roues, c'est un modèle qui a été étudié en Algérie. Et du coup, c'est-à-dire on a fait une comparaison sur l'intensité solaire directe, diffuse et totale. Donc, on a pu comparer d'après la simulation qu'on a fait avec MATLAB. Les résultats obtenus, on nous a indiqué que le modèle de Cap-des-Roues était plus fiable pour les mois de toute l'année, c'est-à-dire pour tous les mois, que ce soit en hiver ou en été. Par contre, le modèle de Bird, on a trouvé que les résultats n'étaient pas assez bons pour les mois d'hiver, c'est-à-dire printemps-hiver. Et cela est dû parce que le modèle a été conçu pour des journées claires. Donc, ça, c'est les résultats qu'on a pu obtenir. Comme vous le voyez, c'est-à-dire avec le modèle de Cap-des-Roues et le modèle de Bird pour le mois de juin, c'est-à-dire les mois d'été, c'est-à-dire on a trouvé à peu près que les résultats étaient presque identiques, alors que pour le mois de mars, c'était typiquement différent. Voilà. Donc, la différence entre les deux modèles a été améliorée selon c'est-à-dire le Cap-des-Roues, il a été amélioré selon la préface de Perrin Prichon. Et c'est pour ça, pour qu'il soit plus adaptable au climat d'Algérie et surtout pour les climats méditerranéens, alors que pour le modèle de Bird, il est conçu de manière à ce que les données météorologiques facilement disponibles puissent être utilisées juste pour les journées claires. Voilà, je vous remercie.
Merci. Thank you for your presentation. Is there some questions, please? No questions. So the following one is for Mrs. Nasrine Benkhemkhem from Mostaganem University in Algeria. She's entitled Removal and an azo dye by adsorption on a green algae. Yeah, you can start.
Oui, bonjour, je vais partager mon écran. Est-ce que je peux partager mon écran?
Oui, bien sûr.
Oui, d'accord. Est-ce que vous arrivez à voir?
C'est en cours.
D'accord.
Voilà, maintenant c'est clair. Vous pouvez commencer et vous pouvez aller directement au résultat.
D'accord. Bonsoir. Tout d'abord, je me présente. Mon nom est Nasrine Benkhemkhem. Ce travail a été réalisé au sein du laboratoire SEA2M sous la direction de Madame Nemchi. Dans ce travail, nous avons tenté d'éliminer un colorant azoïque qui est le réactif Black 5 par absorption sur une algue verte Ulva lactica. Généralement, dans une étude d'absorption, on utilise des charbons actifs pour l'élimination des polluants. Cependant, la synthèse ou bien la fabrication de charbon actif nécessite l'utilisation de produits chimiques qui peuvent être eux-mêmes des produits polluants. Pour cette raison, nous avons eu l'idée d'utiliser des biosorbants comme support de traitement. Nous avons commencé par récolter cette algue, puis nous l'avons lavée plusieurs fois à l'eau distillée, puis séchée et broyée. Avant d'étudier la cinétique et les isothermes d'absorption, nous devons tout d'abord optimiser quelques paramètres, tels que le temps d'équilibre, le pH et la température. Et d'après les résultats obtenus, on peut dire que la meilleure absorption se fait à un temps d'équilibre égal à 2 heures. Et en ce qui concerne le pH, que le meilleur taux d'élimination se fait à pH acide et particulièrement à pH est égal à 2. Pour la température, le meilleur taux d'élimination se fait à de faibles températures. Concernant la cinétique et d'après le dégraphe, on peut dire que l'absorption suit la cinétique du pseudo-second ordre. Et pour l'isotherme, le modèle qui décrit le mieux notre absorption, celui est le modèle de Langmuir. En conclusion, on peut dire qu'on a atteint notre objectif qui est l'élimination du colorant azoïque réactif Black 5 par une algue et on suggère de refaire cette étude avec d'autres polluants. Et merci de votre attention.
Thank you very much. Is there some questions, please?
Est-ce que je peux me permettre de poser une question, s'il vous plaît?
Bien sûr.
Bien sûr,
voilà.
Oui.
Professeur Malik Mazda d'Afrique du Sud, j'aurais bien aimé savoir si vous avez fait une étude sur les mécanismes qui interviennent lors de la réaction de l'absorption de l'azodaï avec quel composant de l'ulva lactica.
Non, on n'a pas le mécanisme d'absorption, c'est ça?
Yes.
On sait juste que non, on n'a pas fait ça, le mécanisme d'absorption, non.
Parce qu'il serait utile d'identifier quel est le composant principal chimique dans l'algue qui absorbe l'azodaï.
D'accord, oui. Vous avez raison, monsieur. Merci pour cette remarque pertinente, monsieur.
Merci, merci.
Je vous en prie, monsieur.
Is there any other questions? So we move to the following one.
Madame, j'ai juste une remarque. Dans le programme que vous nous avez envoyé, vous vous êtes trompé dans mon nom. Nasrine, ça s'écrit avec E, alors que dans le programme, c'est écrit avec Nasrine.
Nasrine, avec un A.
Oui. C'est Kautem.
Oui, je vais corriger. Ne vous en faites pas.
Merci.
Le bouquin final, il y aura toutes les corrections possibles.
Merci, monsieur.
De faire,
Merci infiniment. Merci infiniment, monsieur.
Ça sera corrigé, ne vous en faites pas.
D'accord, je vous en prie. Merci.
Donc, the following one is for Mr. Younes Bennacer from University of Mentouri of Constantine in Algeria. The title is New Fluorantane-based compounds and their use in DSSCS. Please, you can start.
Thank you very much. Do you hear me?
Yeah, I hear you. You can share your screen, please.
Okay.
Partagez, vous pouvez parler en français.
Thank you very much.
C'est aussi quelque chose de... vous faire un exercice.
I think Madam Louisa did very good job with my introduction, so I'm going right to the point. we all noticed that research in the area of sustainable energy sources has generated so much interest in recent years due to increasing levels of energy consumption and the risk of running out of energy and level of prosperity. That result today, solar energy is one of the most important sources of sustainable energy. In this context, we have chosen this work entitled New Fluorine-Based Compounds and Their Use in Dye-Sensitized Solar Cells. And I'm here today honored to present it to you. The objective of this work is to study the potential use of a series of fluorescent fluorine compounds in the SSCs, trying to participate in the search of efficient, cheap, and environmentally friendly energy sources. So we synthesized these three compounds, fluorine-based compounds. I will briefly explain the principle of operation of a dye-sensitized solar cell. In the first step, when the light shines on the cell, the dye molecules are excited from their ground state to a higher energy state, as mentioned in the first equation. The excited dye molecule now has a higher energy content and overcomes the band gap of the semiconductor. And this is crucial for the electron to be injected into the conduction band of the semiconductor. In the second step, the excited dye molecule is oxidized as in equation 2.
You waste your time. This is introduction. Come to the results, please.
Okay, no problem.
You used already 3 minutes, so in principle it's over. Please come to the conclusion or results.
Okay, we did an optical study for the properties of the three compounds and electrochemical study for the three compounds. Analysis of the homomolecular orbitals of the three molecules shows good delocalization of the electron density along the conjugate system. In a conclusion, we can say that based on the values of HOMO and LOMO, these molecules can be used as dye-sensitized solar cells. This is because the energy of the conduction band of the titanium dioxide semiconductor is lower than the energy value of compounds. Energy value of the LOMO of our compounds. In addition, the energy value of the LOMO of our compounds is lower than the oxidation potential of the electrolytic couple oxide. So these results show that our products are good candidates for use as sensitizing dye in dye-sensitized solar cells. Thank you very much.
Thank you for your presentation. Is there some questions, please?
Okay, thank you.
No? No questions? So we move to the following one. It's for Ms. Bouchra Laarabi from College of Education and Research, Mohammed V in Rabat, in Morocco. She's entitled Review on Modeling and Prediction of Soiling Effects on Photovoltaic and Concentrated Solar Power Module Performance. Please, you can start. You can share your screen and start.
Okay, thank you.
All right.
Oh, can you see my screen?
Yeah, it's clear. Yeah, you can start.
You can see, yeah. Because...
But you should skip introduction again.
Okay. Okay.
Also, the title was mentioned already.
Okay. Okay, thanks for the introduction. Okay, so yes, soiling phenomenon is a serious problem of solar energy, as you know. And the main part of the review is based on the content of this this table. So to better analyze the gathered paper, the gathered paper have been divided into two groups.
the theoretical modeling and the statistical modeling. And as you can see here, the research paper gathered show that 68% of the studies concerns the statistical modeling, while only 32% concern the theoretical modeling. And this figure, it shows also that studies on the subjects of soiling phenomenon increase during the years. And this is on the one hand, and on the other hand, it shows also that the statistical modeling, the focus on the statistical modeling is high in the last years against the theoretical modeling. And for the statistical analysis, we can see that the regression analysis ranked first with a percentage of 44%, followed by neural network with a percentage of 23%. And so based on the summary we did, we made also a classification, the following classification, which include all the process of soiling phenomenon. And as you can see, we have three main parts: the weather conditions, the deposited pollutants, and the losses. And from these three elements, we extract 6 groups of modeling. So the first group is the modeling and the prediction of soiling potentials or dust concentration. And the last group, which is EC, which is the correlation between weather conditions and losses due to soiling. And for each group, we present the number of publications for each group. And as you can see, the highest value or number is belong to the group BC, which is the correlation between the losses due to soiling and deposited pollutants. For the group B, also it is an important part, but it is far beyond the scope of this review. That's why we didn't include it. So we made also like a classification of the factors that influence soiling, and based on this classification and the previous classification, we determined the factors that have been used widely to predict soiling losses, and those that were rarely taken into consideration, and we present them in this form. And as you can see here, the factors that have been used widely belong to the group climatic conditions, and mainly the rainfall, temperature, relative humidity, wind speed, and airborne dust. So not taking into consideration the all factors in predicting, not taking into consideration all factors has been considered by many authors as a cause of reaching low performance of their models. So to sum up, the review has shown like a variety of the models used to model soiling phenomenon, and each model has its own strengths and weaknesses. However, to better approach the complex behavior of soiling phenomenon, more data for long periods are still needed. All parameters affecting soiling should be taken into consideration. The same model should be tested in different climates and technologies. The use of existing databases of soiling potentials adjust using weather conditions. Data from existing databases from meteorological stations seems to be a low cost and valuable method to predict soiling losses. This will be achieved, however, only after finding, of course, the accurate relationship between these parameters and validating it on site. And finally, instead of suggesting new models, it will be wiser to test the published models that have proved good results in different sites and, of course, on different technologies to overcome their limits and to achieve the accurate and well-tested models. And I would like, thank you for your attention. I would like to thank all co-authors of this work. I would like also to thank the organizing and scientific committee of this conference, dear audience. Thank you for your attention.
Thank you very much for your presentation. Is there some questions, please? No questions? Okay, we move to the following one. For Ms. Rayane FASSI from Mentouri University in Constantine in Algeria, which is entitled Optimization of Metals Analysis by Volumetric Method, the case of calcium, magnesium, zinc, manganese, cadmium, and palladium. So you can start, please.
I want to ask for forgiveness to Rayane. I wrote her name wrong, so it's Rayane FASSI.
Rayane FASSI.
Yeah. Okay. So.
Yeah.
Je peux commencer?
Bien sûr, vous pouvez.
Merci. Mesdames, Messieurs, chers participants, bonsoir. J'ai l'honneur de vous présenter les résultats d'un travail intitulé « Optimisation de dosage volumétrique des cations métalliques par complexation » qui a été réalisé au laboratoire de pollution et traitement des eaux de l'Université Constantine Algérie. L'objectif principal de notre étude est l'optimisation des conditions de dosage volumétrique des cations métalliques en solution aqueuse en utilisant des réactions de complexation. Les cations étudiés sont le calcium, magnésium et le zinc, qui sont des alcalinotéreux, cadmium et le plomb qui sont considérés comme des métaux lourds, et le manganèse qui est un élément de transition.
Excusez-moi, est-ce que vous pouvez agrandir votre poster, les parties où il y a les résultats?
D'accord. Le réactif complexant utilisé est l'acide éthylène diamine tétraacétique EDTA. Nous avons essayé d'optimiser les conditions de titrage qui sont le choix de l'indicateur de fin de titrage et le pH du milieu. Dans les conditions optimales, nous avons déterminé la limite de détection pour chaque métal. Concernant la détection de fin de titrage, nous avons utilisé deux indicateurs. Le premier est le noir héliochrome et la deuxième utilisée est l'améroxyde. Les essais d'optimisation de l'utilisation de l'indicateur de fin de titrage ont été réalisés à pH 10. Le résultat obtenu montre que dans le cas des ions calcium, le choix de l'indicateur dépend de sa concentration. Le net 0,4 est la meilleure indicateur pour des concentrations supérieures à 2,7 10 puissance moins 4 molaires. Pour des concentrations inférieures, l'améroxyde est meilleur. Dans le cas des ions magnésium et cadmium, seule l'utilisation du net convient. L'améroxyde convient mieux au dosage des ions zinc et le plomb. Afin d'optimiser le pH du milieu, nous avons utilisé deux autres solutions tampons de pH 9,2 et 8,3. Nous avons optimisé le pH du milieu en prenant en considération les résultats obtenus précédemment selon le cas. Le dosage des ions calcium à différents pH montre qu'en présence du net 0,4%, le meilleur pH est 9,2. Le meilleur pH du dosage des ions magnésium reste pH 10. L'améroxyde ne convient pas au dosage du magnésium, quel que soit le pH. Le dosage des ions Zn plus le cadmium en présence de net nécessite un pH égal à 8,3. En présence de l'améroxyde, le pH 9,2 convient mieux au dosage des deux cations. Le dosage des ions Pb2+, en présence du net est meilleur à pH 9,2. L'optimisation du pH pour le dosage des ions manganèse montre qu'à pH 8,3, seul le net peut être utilisé. La combinaison des résultats de l'optimisation de l'indicateur et de fin de titrage et du pH du milieu nous permet de proposer les conditions optimales de dosage volumétrique par complexation avec le DTA des cations métalliques étudiés résumés dans ce tableau. En conditions optimales déterminées, les limites de détection varient de 0,1 dans le cas de dosage des ions magnésium et le plomb à 0,5 dans le cas de dosage des ions cadmium et le manganèse. En conclusion, on peut déduire que le dosage volumétrique par complexation avec le DTA convient bien au dosage des cations étudiées avec les limites de détection inférieures à 1 mg par litre. les conditions optimales de dosage volumétrique par complexation avec le DTA dépendant de la nature du métal. Merci de votre attention.
Thank you for your presentation. Is there some questions, please? No questions, so we move to the following one. It's for Mrs. Souad Tabet from Al-Bashir Ibrahimi University from Bourgois region in Algeria, which is entitled Experimental Analysis and Modeling of Self-Consolidating Concrete SCC Using Waste Glass. Please, you have 5 minutes, you can start. You can share your screen and start.
Okay. Hello, everybody. Donc c'est bon, je peux commencer.
On voit bien votre poster, vous pouvez commencer.
Ah. Okay. Alors, hello everybody. It's my pleasure.
Parlez en français si vous voulez.
Donc j'ai fait la présentation en anglais, dommage. Alors, donc it's my pleasure to present you my work entitled Experimental Analysis and Modeling Self-Consolidating Concrete Using Waste Glass. Donc, alors, comme mentionné ici à l'introduction, self-compacting concrete is characterized by its fluidity, which must be ensured and verified by specific tests, like, donc, we sit here, L-box test ici, stabilization with safe and rheometry tests. In this work, we added the powder of waste glass in substitution with the cement to have a less expensive and ecological concrete with high performance in the fresh state as in the hardened state. The use of modeling by an experimental design simulator allowed us to minimize the number of tests by suggesting the most optimized mixtures before the test and subsequently analyzing the results found by comparing them with those of the simulator, c'est-à-dire faire une comparaison à l'aide d'un logiciel qui est le plan d'expérience. Donc, je m'excuse pour l'explication en français. Alors, donc ici, le travail est basé sur, c'est-à-dire simulation en utilisant le logiciel plan d'expérience. D'où il va nous proposer, ici le plan d'expérience va nous proposer un modèle et par la suite, on va le comparer avec nos résultats. Les résultats sont déduits à partir des essais, c'est-à-dire élaborés en laboratoire. Donc ici, on a c'est-à-dire un béton autoplaçant modifié par substitution d'une poudre de verre. Donc, ici, la spécificité de notre travail donc, est basée sur la modélisation surtout. Donc, le but d'un plan d'expérience, design expert, le but, c'est de minimiser le nombre d'essais surtout. Donc, ici, c'est-à-dire, on va, donc, cette minimisation, donc, je vais continuer en anglais. Donc, the expert design will propose an equation, which links the answers, which is the mechanical resistance here. Donc, il va nous proposer ici un modèle mathématique, une équation. Ici, j'ai pris comme exemple, c'est la résistance à la compression à 28 jours pour le béton autoplaçant. Cette équation-là, c'est-à-dire elle est proposée par le logiciel. Qu'est-ce que l'objectif de cette équation? Donc, c'est la prédiction. C'est une prédiction. Donc, au lieu de faire au futur plusieurs essais, c'est-à-dire qui sont longs et en même temps ils sont coûteux, donc, juste, il faut appliquer cette équation. Je pense qu'elle est claire, l'équation. Donc, ici, quels sont les paramètres? Ici, la réponse. Donc, c'est-à-dire la réponse, c'est le facteur mécanique, la résistance à la compression à 28 jours. Donc, elle est déduite à partir de deux paramètres qui sont le dosage en ciment. Donc, à chaque fois, on fait changer le dosage de ciment ainsi que le pourcentage de la poudre de verre. Donc, il suffit de donner juste les deux valeurs. Donc, et par la suite, on va calculer la compression à 28 jours sans avoir recours au test. Donc, j'espère que c'est clair. Hein? Donc, bien sûr, in order to predict the performance of the concrete without having recours, comme j'ai dit en français, to different tests which are long and numerous. As a conclusion, donc the mechanicals and rheological performance of renovating concrete tip self-compacting could be improved by using glass powder with the design expert simulator. Et merci pour votre attention.
Thank you for your presentation. Is there some questions, please? There is no questions. Thank you. We pass to the following one. It's for Ms. Khadija Ketroussi from Bebzoar University, University in Algeria. His title is Study of SEH hydrogenated amorphous silicon for photovoltaic applications. You can start, please. You have 5 minutes. Khadija Ketroussi is here. Are you here, Miss Khadija?
If she's
no,
not, let's
she's
continue
not
with the
here.
next person. Let's just continue.
Yeah, we pass to the other one. The next one, it's Mrs. Gemid Mouna from University of Hawari Boumediene in Algeria, AlGaAs in Algeria. Her title is Effect of SN concentration on the structural, optical, and electrical properties of indium oxide thin films.
Yes.
Yeah. You can share your and start.
Okay, thanks.
You are welcome.
Good afternoon, ladies and gentlemen. I am Gemid Mouna, and I would like to present something about my PhD project at Semiconductor and Metallic Oxide Laboratory at the University of Science and Technology, Hawari Boumediene. The title of my talk is The Effect of Tin Concentration on the Structural, Optical, and Electrical Properties of Indium Oxide Thin Films. I will start with the introduction, then explain experimental techniques, next present the most result, and finally, I hope to draw a few conclusions. So let us start with the introduction. Tin-doped indium oxide, called ETO, is n-type semiconductor with wide bandgap energy, higher transparency, and low electrical resistivity. This property makes them have widespread application as electrotransparent for solar cell light emission diode. In this work, tin-doped indium oxide were deposited via Sol-Jas spin coating techniques and their properties was studied. The fabrication of ETO films was done through two steps: preparation of the solution by dissolving andium chloride in acetylacetone and tin chloride dehydrate in ethanol. The concentration of tin was taken 6% and 10%. Prepared solution was being coated on glass substrate, and the crystallization process of film was done at 500 for 1 hour. For the result from XRD pattern we see two major peaks 222 and 400 originated to cubic peaks by structure, all film oriented along 400. We noticed also decrease of crystalline size with the increase of tin concentration. From the AFM analysis, 3D micrograph of AFM, this figure presents continuous distribution of pyramidal shaped grain with different size. We noticed that the roughness values of andium doped with 6% showed the value of 24 nanometer compared to 12 nanometer for film doped with 10%. The incorporation of higher concentration of tin affects strongly the surface morphology of andium oxide structure. For optical properties, andium doped with 10% of tin concentration showed better transparency of 80%. The introduce of tin concentration in andium oxide matrix enhanced film transparency. Band gap energy decreased with the increase of tin concentration. Electrical properties were studied through probe point measurement. The resistivity varied between 2.10 power minus 4 and 4.2 10 power minus 4 ohm centimeter. Best electrical resistivity has been obtained for film doped with 6% compared to 10%. Asymmetric tin doped andium oxide thin films with different concentration have been successfully prepared by sample spin coating approach. Prepared film were characterized with different physical methods. The optical and electrical results showed that tin doped andium oxide thin films could be used as transparent electrode for solar cell application. Thank you for your attention.
Thank you very much for your presentation. So is there some questions, please?
I was expecting
Yes.
optimum concentration of tin. Did you determine this?
What?
I was expecting an optimum, the best concentration of tin. Did you try to determine?
Optimum for yes. About when I measured the figure of merit, the transmittance puissance figure of merit, transmittance the resistivity, the values is the values obtain the values.
Yeah, I understand this. But what is the best concentration of tin you determined?
For my work, the aim of my work is the minimize the quantity of andium in the ETO structure. So for the electrical properties, ETO doped with 6% with 10% is the optimized films.
Thank you.
Yes. Thank you. We move to the following one. It's for Mrs. Iman Sharif from Hawari Boumediene University in Algiers, in Algeria. Her title is UV radiation radiation effect on optical and thermomechanical properties of PCBS blend for BFPV application. So you have 5 minutes and you can start. You can share your screen and start.
Thank you.
You are welcome.
Hi, everyone. Hi. I am Iman Sharif, a PhD student at University of Science and Technology, Ambient. And I'm glad to be here with you today and to present my contribution about integrating polymeric materials in renewable energy display. So, due to the transparency, flexibility of the polymeric materials, they are enabled to be used in outdoor applications like in building integrated photovoltaic panels, BEPV, for roofing, cladding, and also glazing applications. So, but however, due to sunlight and the humidity and oxygen in these outdoor applications, so these polymeric materials undergo an aging process. So, as you see, an aging process where chemical degradation occurs and affects their properties and their performance. So, in this study, we used two polymers, polycarbonates and polystyrenes, and to prepare them, we used the solution casting method, where we dissolved them separately using the dichloromethyl solvent, and they were stirred together and then dried. The films, after this, the films were exposed to EVC radiation for 3 different intervals of 2 hours and 2 and 3 and 9 hours. So to detect their UV stability. So like you see here, the dynamic mechanical analysis were used to evaluate the thermomechanical behavior of the films. So our films are known to be viscoelastic. So here you can see that the stiffness of the films at the range of temperature and the TG temperature of polystyrene, because they are not viscous, so they do have 2 different temperatures. It was affected, and the films were the film specialist that of the 9 hours was brittle and was but all of the films were stable at this range before the first TG, and also here, like you can see, the temperature, a slight decrease in the modulus toward high temperature in the rubber plateau was observed too. So indicating, especially here, indicating that the molecular weight decreases and the flow phenomenon was accelerated to be happened. And in here, so for the results of loss factor results, they showed considerable change also toujours for the samples irradiated for 9 hours, where the relaxation, the temperature was affected. Also, the relaxation, so which is the loss factor, also was increased, indicating that the temperature, the change station was occurred in the phase of polystyrene. And as you can see here, and you can see the initial stiffness was also decreased with a decade for the the sample irradiated for 9 hours, that you can see here. And here, this is the tableau récapitulatif for these results. So also to see the reaction of the interaction of the polymers with the UV and the visible light. We ran our samples into UV visible spectroscopy, and we found that the films react slightly here in the visible region from 400 to 800 nanometers, and a slight decrease of the transmitters. So here for the comparing the original films with the films irradiated, so which may affect the light management of this polymer and the BEV application. And in conclusion, the results of VMR showed that the absorption of UV radiation was not only limited on surface, but also in the volumic material, the volumic range, and this is all of this is was caused by the change scissions of both polymers, the components.
You have finished?
Yes, I have finished.
Thank you very much. So, is there some questions, please? No, there is no questions. So we pass to the following one. It's for Dr. Sameh Boudiba from Laarabi Tbilisi University in Tbilisi in Algeria. The title is Experimental Investigation of Plant Extracts as Corrosion Inhibitor on Carbon Steel in Acid Solution. So you can start.
Sameh, are you there?
Share your screen. Share your screen, please.
Good afternoon, ladies and gentlemen. Before starting my presentation, I would firstly like to thank ANSOL and to wish for ANSOL for its 10th anniversary all the best. I would like also to thank Professor Egbe for the effort provided to have African research in their research and, by the way, completing their PhD and more. I want to briefly present myself. I am Sameh Boudiba from Tbilisi University. I am one of the PhD students who benefited from ANSOL scholarship, and it was the reason why I complete my PhD. So I have today the honor to present you this contribution, which consists a part of the effort provided by our team to look after an eco-friendly, cheaper alternative to the toxic chemicals used to inhibit steel corrosion in different aggressive media. Faced to the awareness of the importance about healthcare and environmental protection in the world, the use of plants which constitute a divine gift known to be the main source of secondary metabolites with their remarkable structural diversity and various activities, constitute an important eco-friendly alternative to toxic chemicals to inhibit corrosion. In order to do so, in this contribution, we used the plant extract to inhibit corrosion. And in this study, we present a gravimetric study to see the efficiency of these extracts against corrosion. So
you have some windows on your screen which block the poster.
Sorry.
Close these windows. There are gray areas.
Okay.
Yeah.
I think you have to close some windows which are open.
Okay.
Beside your presentation. No, it's not better. But if you don't manage, then just go ahead, please.
Let's go ahead. Let's go ahead.
Okay.
You can continue.
Okay. Okay.
Just continue, please.
You can continue.
So as we see, here we used at different temperature, we used the extracts at different concentration. And finally, at the optimum concentration, the high efficiency we got a high efficiency for this extract to inhibit corrosion for the carbon steel. This is the most important work and results of this contribution. Thank you for your attention.
Thank you for your presentation. Is there some questions, please?
And I just want to say that I'm also very proud of Same Boudiba, who came in our lab 2012 and who had to learn to do synthesis from scratch. And she learned very fast and did wonderful work. We published very good papers. She could complete her PhD very nicely. And she's now assistant professor at Tlemcen University. So this is one of our fellows, which gives us joy to celebrate our 10th anniversary today. So,
Is there some questions, please? So we move to the following one. It's for Soumia Fessi from Constantine University. Soumia is here?
Yes.
Yeah, you can start, please. You have 5 minutes. Share your screen, please.
Yes. Je peux commencer?
You can start, please.
Merci, madame. Mesdames, messieurs, chers participants, bonsoir. J'ai l'honneur de vous présenter notre travail intitulé « Efficacité de plusieurs méthodes photochimiques pour la décoloration du rouge de cresol présent dans l'eau et de la lumière solaire ». Ce travail a été réalisé au laboratoire des sciences et technologies de l'environnement en Algérie. Les principaux objectifs de notre travail sont la décoloration et la minéralisation d'un colorant cationique qui est le rouge de cresol par le procédé Fenton et Photofenton en lumière artificielle et solaire. Puis, on a optimisé les différentes conditions opératoires. Au cours de ce travail, nous avons utilisé une enceinte cylindrique équipée de 3 lampes imitant principalement à 254 nanomètres et aussi une pelote solaire qui est utilisée pour la décoloration par l'énergie solaire. Le colorant modèle choisi est le rouge de crésolol qui appartient à la famille de tréphénylméthane, est un colorant cationique. L'analyse des échantillons se fait à l'aide d'un spectrophotomètre EV visible pour la décoloration et pour la minéralisation, on a utilisé un DCO-mètre. L'ensemble des résultats obtenus sont récapitulés dans ce poster. Donc, on commence par le procédé Fenton. Nous avons en premier lieu optimisé le rapport H2O2 sur fer2. Les résultats obtenus montrent que le meilleur rapport est égal à 5. Ensuite, on a optimisé le pH. Selon plusieurs auteurs, le pH optimal de la réaction de Fenton se situait alentour entre 2,5 et 3,5. Notre résultat confirme cette hypothèse. Donc, puis, on a fait la décoloration du rouge de crésolol, associer ce système de Fenton en premier lieu par les rayonnements UV, puis en lumière solaire. Concernant l'utilisation du rayonnement UV, les résultats obtenus montrent que la disparition totale du rouge de crésolol est obtenue au bout de 30 minutes pour le meilleur rapport qui est toujours 5. Afin d'améliorer la décoloration du rouge de crésolol, nous avons couplé le système Fenton par l'énergie solaire. Les résultats obtenus montrent que la décoloration du rouge de crésolol est plus rapide en lumière artificielle qu'en lumière solaire. Ceci pourrait être attribué à l'augmentation de la température. La comparaison entre les différents procédés étudiés montre que le procédé photofenton à 254 est le plus efficace pour la décoloration du rouge de crésolol. Ce qui concerne la minéralisation par la DCO, les résultats obtenus montrent que le procédé photofenton à 254 nanomètres est toujours meilleur. En conclusion, on peut déduire que le procédé Fenton et Photofenton sont efficaces pour le traitement des eaux polluées par les colorants textiles. Merci pour votre attention.
Thank you very much for your presentation. Is there some questions, please? No questions, so we move to the following one. It's for Mr. Borisad S. Benga from Federal University of Ekiti in Nigeria. The title is Processing, Characterization, Mechanical and Wear Behaviors of Magnesium, Reinforced Aluminum Alloys and Nanocomposites Review. You can start. Are you here, Mr. Borisad? Mr. Borisad is not here, so we move to the following one.
Just wait, he's coming in. He's
coming. Okay.
He's just coming in. Yeah. So, Mr. Borisad, hello. Borisad Mbega, are you here? I just let you in.
Okay.
Maybe he has some problems, some connection problem.
We can leave him to the end.
To the end, yeah.
Yeah. So we move to the next one. Professor Elif Ariti, Energy Institute, Istanbul Technical University from Turkey, the Gender Energy Nexus.
Elif.
Professor Elif.
Damian. Please, I am Khaled Blouchet. I want to present my work entitled application and the study of nano anti-contamination for photovoltaic panels.
Please change your screen.
I am sorry for his delay. Okay.
Share your screen.
Yeah, okay. Actually, he will have presented in the afternoon, but now that he's there and the other people are not ready, let him present.
Okay.
So,
start.
Yeah, you can. Can you share a screen?
Okay. My presentation.
You have to share your screen. Il faut partager l'écran.
Une minute.
Partagez l'écran.
Oui.
Oui, alors cherchez votre présentation et montrez-nous.
Okay, you look my presentation.
Yeah.
Okay. My presentation, the title of this study and application of nanotechnology anti-contamination for photovoltaic.
Excuse me, but he's not in the program.
Why?
You are not in the program.
Yes, in the program for 40.
Ah, okay.
Okay. I have the line. Okay.
Continue. Present.
Okay. Aims in this work application of titanium dioxide nanomaterial in photovoltaic panels for its change its performance, and the second found by the collection of fine particle gas and water from the above the solar panel that prevents sunlight from reaching the surface of the solar cell, self-cleaning. Solar energy is cleaner and sustainable than any of the other energy statements, and drop of efficiency of a solar PV panel is due to the disposition left by bird pollution and the dust caused by traffic or from the agricultural activation. The only one for the found essential for this study, the application of nano-coating dioxide titanium coating is one of the possible solutions, and a nano-coating replaces dust, pollen, and other particles and could keep solar panels clean and operating at their peak efficiency longer than conventional panels. Dioxide of titanium based photocatalysis has attracted wide attention as a promising technique for environmental remediation in the past 30 years because of its strong oxidation power and photo-induced hydropholicity under UV radiation. Dioxide of titanium coated substrates show very clear self-cleaning performance when they are exposed outdoors. This behavior is illustrated in these figures. viscous organic layer accumulates and the dioxide titanium films are oxidized finally into CO2 and H2O, and then the residual deposits on the surface can be easily washed away by rain. For the determination of dioxide of titanium in the surface, I utilize the soldier dating method for counting is used for preparation of counting the films. Evaluation of counting property on a the most of application of counting for surface of panel. The contact angle was measured on the counting surface to evaluate this hydrophilicity. The measurements were done before and after PV radiation at different times. After 75 minutes, the contact angle was below 30 degrees, indicating that this is the minimum UV radiation time required for the coating to have a self-cleaning characterization. The value show significant decrease of this deposit. Okay, the deposit of surface for the determine self-cleaning of the panel and on the coating sample compared with the uncoated sample. The result obtained the enhanced performance of the coating sample is due to the several factors. In the figures 1, the first figure, the centuries material is dioxide titanium anatase, which is we know for its high photocatalytic activity. The self-cleaning process uses dioxide titanium films involves 2 stages. The first supply of organic dirt via photocatalytic process in the presence of ultraviolet light. This stage is very critical as it reduces the presence of the stick materials. And the second factor is the hydrophilicity of dioxide titanium and films coating of solar panel in desert and arid region is preferred to be hydrophilic. Science further showed that cleaning for time to time using water is essential to eliminate the dirt from the party and the surface by the diffusal of water to the white surface. Illustrate of this study and gather and hence raising the dews. For conclusion, solar panel need a clean surface to gather light efficiently from the sun, but they are often solid by water and debride, then can reduce their power capability. Nano coating repel dust, pollen, and other particles and cold keep solar panel clean and operating at their peak efficiency longer than conventional panel. A self-cleaning nano than hydrophobic coating layer repel water and particle without interfering with the solar panel ability to absorb sunlight. This coating can last 2 to 4 years, reducing maintenance and operation cost. Thanks for your attention.
Thank you very much for your presentation. Is there some questions?
Yes, I have a question, please.
Yeah, please.
I would like to thanks for this nice talk, and I would like to ask the author to go back to the slide about the simple preparation, please, if he can go back to this slide on the simple preparations.
Simple preparation.
I don't see anything.
Share your screen again, please.
Okay.
Okay. Thank you. Thank you.
For preparation of the self-cleaning of the soldier method. Okay.
So could you please give more details and more explanation on how do you prepare your samples, step by step, please?
I mélange for dioxide de titanium for mixture appareil, and I doping the dioxide de titanium for surface of panel in the Solzal method. Okay, evaporation and the fixation the dioxide de titanium in the surface. The Solzal method give in the all literature. Do you speak for and explain explanation for this method?
Okay. What about the measurement of contact angle, please? How do you do to measure this parameter?
Contact angle and the UV radiation. UV radiation apply for UV radiation for measurement the contact angle of the dioxide of titanium and the substrate.
No, but I don't know exactly how do you do. How do you perform such measurements? Because it's not easy to perform this measurement. This is why I would like to ask you to
using appareil UV appareil. Okay, for measurement the contact angle. For detect the angle, the phase of angle for determining of dioxide of titanium in the surface of panel and all substrate for materials.
Thank you.
Do you think?
Thank you.
Okay.
I have questions, please.
Thank you very much.
There is Dieter Meissner who has also a question.
Yes.
Yeah.
Firstly, I come to remercier the presenters. My questions have you shown an effect while we're using the this layer, coating layer. Pourquoi vous avez choisi le TiO2? Bon, je pose la question en français pour que le présentant...
Oui, il peut répondre en français, pas de problème.
Yes. Ok, je comprends beaucoup plus. Est-ce que vous avez remarqué l'utilisation de cette couche TiO2 a une influence sur l'efficiency, storage of energy?
Parce que le titanium, dioxyde de titanium,
yes.
the characteristic of this materials, it's auto-nettoyant, self-cleaning for the radiation of soleil, provoke of CO2, dioxide de titanium, for self-cleaning.
Yes.
Okay.
En voyant la caractéristique IV, il y a une influence. La dernière courbe, résultat que vous avez présenté, le IV. Bon, une autre question. Est-ce que vous avez choisi le thickness of this layer?
Yes, the thickness in the nanometer.
Nanometer.
Yes.
Parce que ça influence beaucoup les...
Couchements for thickness. Efficient.
Okay. Okay, thank you.
Thank you very much.
Okay. Thank you,
questions?
Thank you, madam.
You are welcome.
I think Dieter wanted also had a question to ask.
Yeah, I'm very much wondering about these nice results, because I would not think that the titanium dioxide helps against dust. So I'm wondering, how did you showed in one of your photographs these modules which were coated and uncoated, and they look absolutely perfectly coated. So I don't think this is because you left them outside just for some time. So how did you prepare this dirt layer actually? I can't hear you.
Hello, Monsieur Khaleb.
I think he left already.
How can you leave it? Khaleb?
His microphone is muted.
Yeah, can you, Mr. Haleb, can you put on your microphone?
Oui, Monsieur Daniel, professeur.
Oui, tu as écouté la question de Monsieur Meissner?
No, I don't think that the question.
Dieter, can you repeat the question, because he says he did not follow up?
The photograph shows a perfect gray layer on the non-coated and nothing on the coated. So it does not look like a module looks after being for some time outside. So you probably prepared this dirt layer artificially. Can you tell us how you did this? How did you deposit this dirt?
I can't hear.
I ask you,
I can't hear the question.
How did you prepare the dirt layer? Because it does not look like it looks outside.
For this, the pollution, artificial pollution. I estimate the pollution in the supposed the MTL pollution for pulverization method. I pulverization, the dioxide of titanium in the surface.
No. I
I
know very well how to deposit these coatings. I was working with Fukushima and Honda, who developed this technique. So I know very well how to make titanium dioxide films. What I don't know is, how did you prepare this dirt film, this gray layer on your photograph? Because if you leave a module outside, it looks completely different. It never has such a nice homogeneous coating. So how did you make this dirt coating?
Le professeur demande comment as-tu fait la couche avec la poussière.
Excuse-moi. Oui, pardon. Pardon, Daniel. Est-ce que je peux juste ajouter une petite précision pour que l'auteur puisse comprendre un peu la question? C'est une question très importante, très pertinente.
Oui.
Si ça ne dérange pas, Daniel, c'est bon?
Non, il faut ajouter, oui, parce que nous sommes là.
Parce que le professeur demande une question, il dit qu'il voit que la couche de salissure déposée sur le module photovoltaïque, c'est une couche qui ne semblait pas naturelle. C'est une couche de salissure qui n'est pas naturelle. Elle a été déposée peut-être d'une manière artificielle ou d'une autre manière. Parce que si la couche était naturelle, on aurait trouvé une certaine inhomogénéité, un aspect inhomogène de la couche d'encrassement ou bien la couche de salissure. Vu que la couche montrée dans la présentation, c'est une couche qui est presque homogène et qui donne la sensation, ou disons, l'impression que ce n'est pas vraiment une couche de salissure naturelle. C'est ça la question du professeur.
Monsieur Aralep, vous êtes encore là?
I think he lost connection. He's not here anymore.
Okay. I think then we will...
He is the last person.
Yeah, I don't know whether the other guys, Burisa Mbega.
Some problems, yeah.
Burisa, are you still here or you've gone? Burisa Mbega, Federal University.
Burisa has some problems with his network.
Okay, yeah, there's a problem in Nigeria.
Yeah.
Okay, I think then we can say that we've gone through the whole day. Just maybe 2 lectures were left in total. So this is a big success for the day with more than 20 something, I don't know, 30 lectures today. I'm very grateful. So for this 10th anniversary celebration, this 4th of February, and for all those who presented today, starting from Professor Sarisifchi to the last presentation, which is very interesting, if he could give some explanation at the end, but having self-repelling, self-cleaning solar panels in Africa, this is something very, very important. I visited the largest solar field in West Africa that Professor Moussa presented today in Burkina Faso. I think Dieter were also there. And we saw the issue of cleaning. So they had to be cleaning almost every, I don't know how many hours, the solar panels because of dust. So there is waste of water, there is waste of energy just to keep the solar panels clean. If one can develop something which is self-repelling, this is self-cleaning, which is, this is going to be a wonderful issue in Africa. So Mr. Khalef has come back again, but I think we should, I don't know whether he is ready to give some last explanation or and answer the question of Professor Dieter Meissner, but if not, we just close up the day by, as I said, thanking all the moderators, thanking all the presenters, thanking all those who participated by listening or by asking questions. And I'm happy to see Abdel Fattah Badadi towards the end of the day. That's one of the founding fathers of Ansol, not only at the initiation in in Sousse on the 4th of November, but also at the launching on the 4th of February 2011 in Linz. So these are people who have accompanied Ansol from the onset until today. And I'm proud to see you. I'm proud to see Luisa, Dieter Meissner, and many of you who have been accompanying Ansol, whether with a summer school or conference or whatever. I'm so proud that we've got to this point of this milestone. We've achieved this milestone of 10 years existence of Ansol with many nice achievements. Students who have completed, who are now themselves lecturers, assistant professors. Some will become professor very soon, full professor very soon. I'm so proud. It gives me a great joy. I know the pathway was not easy to get here. We had support. Sometimes we had enmity. We had pressure. But it's normal whenever you're advancing. You have people put a stone on your way, but what I've learned in my life is never to give up. If you are convinced that what you're doing is right, one day people will see that, yeah, really what you're doing is right. So, but if you give up when the storm comes in, then you will lose. And so is today because I never gave up, and I continue in difficult times to stand firm on what I believed, and we are where today. And I want to thank all those who helped me, especially when I had difficulties. I want to say, I know Professor Lang is not here now, and I can praise him when he's not there. So he was there when I needed him most, and he helped me. Professor Lang of the institute where I now working. He supported me, and I want to say thank you in his absence. I want to thank him through Harakike, who is now supporting me in this, giving us this technical support of this event today and tomorrow. I just thank the whole Institute of Polymeric Material and Testing of JKU Linz, and I thank Professor Sarisifchi once more, who helped us to start. I thank Samir Ramdan and Amel Benfred, who are now my friend and family. There are so many people, so I'm so full of joy today, and I know it's just the beginning. At one point, I have to pass the torch to somebody else to continue this wonderful journey of Ansol. And I believe through the grace of God, and I believe in Christian, and God has always been on my side, even in the hard times. The same God who brought us up to this level, I'm so convinced he will take us in the next decade, and he will take us more, whether I'm living or I'm not living. And Saul will continue with Daniel or without Daniel. God gave a word in Revelation chapter 3, verse 8, that he has opened a door and nobody can close it. And I'm so sure nobody, myself, and I cannot close that door. It's a movement which has started, and this movement will continue with me or without me. And I'm so proud that we've got, at least God has used me to get to this point of the network. So thank you all for those who have stayed up to this moment listening, and those who are going to follow up these lectures, or what I'm now saying on YouTube, because it is recorded for YouTube, and you always can go through and listen. I want to say that thank you, and at most I thank God for his support from the initiation in Sousse till this day that we're celebrating the 10th anniversary. So I wish you a wonderful evening. People are different in different continents. Maria Teresa is in Mexico, so her day is still has a long day, and others which are in different time zone. Wherever you are, I wish you a wonderful 4th of February, this special day of our 10th anniversary celebration.
We cannot finish without thanking you. So there is the possibility, as you can see on your screen, to applaud. So let's thank Daniel at the end with raising our hands for applause or showing it in the camera. Thank you very much, Daniel.
Thank you too. Thank you. Thank you. Thank you. Thank you. Okay, so have all of you a nice evening. So we see tomorrow we're going to have very interesting talks, which has some big political impact between the relationship between Africa and Europe. What Professor Lang is going to present tomorrow as keynote lecture. He has some connection with the government of Austria, and I think I believe what he's going to say tomorrow will have an effect, long-term effect on the Euro-Africa relations, especially the Austrian, when it comes to Austria-African relationship. So let's come in great number tomorrow to listen to his talk. And there are going to be interesting talks. Many talks tomorrow are mixture of water-related lectures and OPV and other issues, batteries, and some posters at the end of towards the end of the day. So please come in mass as you came today, and let's celebrate our 10th anniversary. The second day with enthusiasm and joy. So have a nice evening, sleep well, and we'll see you tomorrow. I thank Harakika for being patient with us all through this day, and I hope you'll be fit tomorrow to support, to give us your technical support also tomorrow. Thank you, thank you, thank you, thank you. So have a good night. Bye.
Bye-bye.
Bye.
Bye, Daniel.
Bye.
Have a good night. Bye-bye.
Bye-bye, everybody.